Hey guys, today we're starting the second chapter, which is all about powers. So anything that has an exponent. We'll start today just by going over how we model powers and what they really mean, as well as how to cancel them out. Okay, so this is lesson 2.1, modeling squares and cubes. So when we talk about powers, just some terms to know. The power is the entire thing. So both the base, which is the large number, as well as the exponent, which is the smaller number. When we're talking about powers and what they're used for, powers are used to represent repeating multiplication. So if we write 2 to the power of 3, we're saying that the base is multiplied by itself, however many times is represented by the exponent. So 2 to the power of 3 means 2 is multiplied by itself 3 times. A perfect square is a certain type of number that we can square root and still get a whole number. So for example, 49 is a perfect square because we can take the square root of 49 and still get a whole number, in this case 7. Another way of saying that is that we can square a whole number to get 49. So 49 is a perfect square because 7 squared is 49. A square root and a number squared are opposite operations. So squaring something and square rooting something will cancel each other out. So for example, if I have the square root of 7 squared, that squared and the square root will cancel each other out and leave me with just 7. And the way that we model a perfect square is just by drawing a square and then writing the number on either side. So for example, the way that we would represent 49, which is a perfect square, is to write a square which is 7 by 7 because 7 squared is 49. Okay, perfect cubes work much the same way. A perfect cube is a number that you can cube root and still get a whole number. So for instance, 8 is a perfect cube because we can take the cubed root of 8 and get a whole number. The cubed root of 8 is 2. Another way of saying that is that we can cube a whole number and get our perfect cube. So if we take 2 and cube it, 2 cubed is 8, so 8 is a perfect cube. Just like with square roots and squaring things, a cubed root and a number cubed are opposite operations and will cancel out. So if, for instance, I take the cubed root of x cubed, the cubed root and the cubed will cancel out and leave me with just x. And the way that we model this is to draw a cube, then label both the height, length, and width with the same number. So this is how we would represent 8, because 2 times 2 times 2, or 2 cubed, is 8. And the reason this little v is here is that the volume of this cube would be length times width times height, or 2 cubed, which is 8. Okay, let me know if you have any questions about this stuff.